Example 5.5. Using the finite difference method to approximate the solution to the boundary value problem of example 5.2 from the book. So the questions involves ei d2y dx square equal to 1 over 2 wlx minus 1 over 2 wx square, and the step size is given h equal to 2 for L 10 meter E I W given values here, and the boundary conditions y0 0 and y10 equal to 0. To solve this, we have to substitute the parameter values inside the equation. So E is 210 multiplied by I then we substitute the value of W, L, now by multiplying the values, you will obtain this. Note that for finite difference method, the coefficient of d2y dx square must be 1. So we divide this value and then you will get this. So this is the differential equation. Okay, so we will use this by using finite difference method. Step 1. First, we write into general form. So the problem here, the differential equation can be rearranged as y double prime. We bring the value to the left. Okay, so before we do that, let's examine, is it necessary to bring to the left? Okay, look here, this is y double prime, and do we have y prime here? No. Do we have y? No. So this one will remain at the right hand side. So what you have here, y double prime equal to this. And if you compare this, so your P is 0, Q is 0, and then this is R. Okay, so we identify P equal to 0, Q equal to 0, and R equal to this value. So this is the application problem. Now we do the following step. Step 2 is identifying PQR. Step 3 is find the step size. We already have the step size actually. We want to know the number of intervals. The step size formula is this. The step size is given as 2. Xn, what is Xn? What is X0? The first value inside y is X0 and this one is Xn. So xn is 10, x0 is 0. So here you know 2 equal to 10 over n, and you can calculate n, 10 over 2, which is 5. So now we know that we have 5 sub-intervals. Then the formula of finite difference method, you can refer to your maths formula book. Make sure you write this correctly. Be careful for the index, yi, and so on. Okay, so this is the formula. So we want to plug in all the values. Okay, so that delta x is 2 over 2, your pi is 0. And then on the right hand side, since it has long expression, so I put down here, and we want to write the ri, so each x should be replaced by xi. Simplifying, this term will 0, this one is 0. Okay, so this is the formula of finite difference method for your case. Now in step 4, we construct the iteration table until 5. Why we know 5? Because we already calculate using the time step. So the first value of x start from 0 by the step size 2, so you add 2 for each. Now this is the sequence of xi. Now for yi, the first value when x0, look at the boundary condition. When x0, y equal to 0. When x equal to 10, y equal to 0 as well. So we know the boundary condition, here is 0 and here is 0. So you have to find the interior part, y1, y2, y3, y4. Okay? So now you know that for each I, so you want to know at I equal to 1, right? So set I equal to 1. So by writing this expression based on each I, you will get this. Okay, now look, y0 is the first value of y, which is 0. You can replace that. x1 is 2. x1 square is 2 square. Okay, then you can simplify this. You will get after you replace those values, you will get this expression. So we continue with I equal to 2. Now your R, the right hand side become x2 here. So look at each term. We don't know any value except for x2. x2 is 4. x2 square is 4 square. Then we simplify this. Next is I equal to 3. Now it is x3. So look for each term. What we can replace here is x3, which is 6. This is 6 square. Lastly, you have to do for I equal to 4 as well. So now you will have 4 by 4 matrix, yeah. And like another example, we have 3 by 3 matrix, but now for this case, based on the sequence and the discretization, we will have 4 by 4 matrix. So let's replace what we have here. y5 is another boundary condition which we know equal to 0, and x4 equal to 8. Okay, this is 8 to the 4. Now from this iteration, okay, this one, and this one, you want to construct the matrix, okay, in step 5. It is tri-diagonal matrix. Now your unknown has y1, y2, y3, y4. On the right hand side, I will fill the right hand side first. And then we have the matrix 4 by 4. So as you see, the matrix, the coefficient of the left hand side can be written as -2. So this is the matrix. Now we want to solve the matrix by using Thomas algorithm. So Thomas algorithms has a table as well. So we have I, and we want to make 1, 2, 3, 4 column, because I has 1, 2, 3, 4. So we need to fill in the first 4 rows by referring to the matrix. B is the value of the right hand side. Remember, this is the value of B. This is the value of D, diagonal. This is C, start from C2. And this is E, start from E1. Okay, so we want to copy the value here. Okay, C has no value, 1, 1, 1. And for D, all are -2. And for E, 1, 1, 1, no values. First, we want to calculate the alpha value. Alpha 1 equal to -2. Okay, you have to follow the Thomas algorithm. And the step of finding the box is from alpha 1, then followed by beta 1. Then you need to find alpha 2, beta 2, alpha 3, beta 3, alpha 4, beta 4. So the result is written here. You can verify this. Okay, then you have to find the value of W. This is the night bulk, 10, 11, 12. We need to fill in the value of W. Now, lastly, let's find the value of Y. Start from the backward. 13, 14, 15, 16. So this is the solution, okay? So you have to make a conclusion. Your result is on the last row here, but you have to rewrite for the reader to know. Okay, therefore you can list down your Y1, Y2, Y3, and Y4. That is the end of the solution by using finite difference method.